In this video, we're going to cover database security as it relates to data protection. So we're going to talk about relational databases first, and then we'll dive into SQL injection. So in order to understand a database, you need to understand that it is made up of a bunch of tables, and these tables have columns that represent characteristics about the specific table, and they have records that are rows in that table. Each of these tables have a unique key that is going to identify the record. And for each piece of our database, we have different levels of access that we can restrict. We can restrict access to the structure of the database. So this is preventing people from being able to see how the tables are connected, etc. We can also restrict access to the database entirely. We can also restrict access on tables themselves. So we can give people access to a database with only access to certain tables or objects in that database. We can also restrict access to rows. This may be done through views. We may restrict access to columns, also done through views as well. We can also restrict access to data granularity, such as certain calculations. So one of the biggest threats to our database is SQL injection, which is manipulating the form to trick the database to be able to reveal certain information or insert certain information or delete certain information from our database. This is one of the most common vulnerabilities that we see across companies, and it falls among the top list of ways databases are compromised. So here are just a few examples that we've seen in the news of huge security breaches. Even MySQL has had a database breach through a SQL injection. So let's walk through a few SQL injections. The first one is the dynamic query. So here on the left, we have a customer search form where they can enter in a customer ID, hit the submit button, and it should return the customer information. On the back end, the code would look like this, where we would select the name, street, city, state, zip code from the customer table, where the customer ID is whatever the user puts into that form. So that's what this post customer ID is representing. So if someone enters a valid query of 101, what it should do is return the customer that has that information. If we do not properly protect against SQL injection, someone can use a numeric SQL injection by saying 101 or 1 equals 1. So the customer ID equals 101, that's true, but also when is 1 equal to 1? 1 is equal to 1 always. So this means we're going to return all customers regardless of whether that 101 is a match or not, because it's going to return true for every record. So we will get a list of all the customers in the customer database. So let's have you guys attempt a numeric SQL injection on your own. So log into the server, go to the course directory, look under SQL injection, specifically the numeric exercise, and then read the page description and do what it says. Your goal is to execute a numeric SQL injection that shows all users. So pause this video, try this on your own, and then come back to compare your answer. Okay, so here's the page that we are supposed to try to execute a numeric SQL injection to return all the information of our users. So if I were to select one user and just hit the submit button, we would see all the information associated with this user. As part of this exercise, I actually show you the query that was executed. So it says select start from users where the user ID equals 109. So each one of these users has a number, and we can actually see the information for each of one of these, such as belly flop, page turner. So what I'm going to do is inspect this page, and then I'm going to pick this drop down, which we will manipulate to return more than what is expected. So by picking it, it selects the element that I'm going to manipulate. So I'll go ahead and open this, and we see values. This is where I'm going to perform the SQL injection. So I'll just say 109 or 1 equals 1. And now I got to make sure that I have Absidy Smith selected. I'll go ahead and submit this form. And sure enough, we return all the users and their information. Although there were only 3 in the drop-down menu, we can see all the users now. The next type of SQL injection we're going to talk about is the string SQL injection. So again, here is a login form where the user would enter their username and password. The query on the back end would look like the code on the right, where we'd count the number of users, where the username is equal to the username that was provided, and the password is equal to the password that was provided in the form. So a legitimate query would look like this. A user enters in their username and password, and then the query would check whether or not the username and password exist in the database. If so, it will result in a successful login. However, if someone were to perform a SQL injection, they can bypass this login and still get in. So the manipulated query string here is we're going to type in Ormond, quote, space, # into the username form element, and then we can just leave the password blank or just type whatever we wanted to in the password. What the first quote is doing is ending the previous quote, And then the pound sign is commenting out all the rest of the lines of code. So it will just ignore the rest of the code that is in this query. So this would result also in a successful login. Because this is only checking whether or not a user with a username at Ormond exists. It doesn't matter the password. And because a user with a username at Ormond does exist, it would log in. So let's have you try another SQL injection on your own. So go to the server again. This time under SQL injection, we're going to open up the string SQL injection page. Read the page description and do what it says. The goal here is to execute a string SQL injection that would log in as a user without entering a valid password. Okay, so here we are at this page. We are going to try to log in as bbaggins with this password. Just to show you that this works, I'm going to log in with bbaggins legitimate credentials. So 1 password, 2 rule them all, with every word capitalized. Hit login, and it says the credentials I entered are valid, but now we want to try to log in without using valid credentials. So again, I'm going to type bbaggins, and I'm going to just type in some random characters, and this shows you that the password actually failed. So it says select username from security user where the username equals bbaggins and password equals this. So what I want to do is have just the username and get rid of the rest of the query. So I need to type in bbaggins and then comment out the rest of this. So I'm going to just paste that here, and then I'll put a pound sign at the end of this, and then for the password I will just type in anything. I'll go ahead and hit login, and it says that we successfully logged in without providing legitimate credentials. Another SQL injection we need to be concerned about are chained queries, which basically allow for stacked SQL injection. Essentially what I'm doing is I'm taking a form entry and entering in multiple queries rather than the single query that is intended. So take, for example, this form where we're asked to enter in a supervisor ID. The query on the back end is going to interpret this and return all the employees that have that supervisor ID as their supervisor. So a legitimate query is going to look like this. Select star from employee where the supervisor equals 3. This would then return all the employees that are supervised by this employee. A stacked SQL injection would basically allow the user to end this query and then run any query that they want. So take, for example, if they typed in 3 semicolon update employee set salary equal to 100,000 where employee ID equals 3, what this is going to do is first it's going to end the first query with a 3, which is going to give us the results like the other side. However, it's also going to change the salary of employee ID to 100,000. So what I want you to do is try stacked SQL injection on your own. So go to the web server, go to the course directory, and under SQL injection, open up the stacked SQL injection. Read and follow the page description to do what it says. The goal here is to execute a stacked SQL injection to remove all records from the security user table. So pause this video, try this on your own, and then come back to compare your answer. Welcome back. So here is the stacked SQL injection page. What we're going to do is remove all the users from the security user table. So I'm going to go ahead and right click this because this is a drop down, and we'll inspect it. And what I'm going to do here is change one of these values to do something that it shouldn't. So I'm going to say 2, and then we want to delete all the users from the security table. So we'll delete from security user, and this would remove all the users from the security user table. I'll go ahead and click submit, and sure enough, it removes all the users, and we get a success message. Additionally, I could have also dropped the security user table. So go ahead and run this, and we removed all the security users by dropping the table. The final SQL injection that we're going to talk about is the blind SQL injection. Basically, this is where the user has no idea what the value could be, and they just kind of guess between ranges until they finally narrow down to the exact value that they're looking for. So take, for example, we have a form entry where the user is to enter in a customer ID. This would then return the information for a specific customer. So the backend code is going to return the name, street, city, state, zip code from the customer, where the customer ID is whatever's entered into the form. So a legitimate query would look like this. We have select name, street, city, state, zip code from customer, where the customer ID equals 101. We'd then get the results on the right. So let's say that a hacker is trying to figure out the customer's additional information, such as credit card information. So what if they were able to attach through trial and error a bunch of different values to figure out if they get results? And if they get results, then they know it's a valid PIN. If they don't get results, then they know that it's not valid and they can keep narrowing down the results. So for example, here they're just going to add another query to the end of the existing query that will say and what this query is going to do is it's going to select the pin from the customer table where, and then it's going to do a substring. Essentially what the substring is going to do is it's going to look at the credit card number, grab the last 4 characters of the credit card number. If it's equal to 4,405, then we have the number that we're looking for. And then it's going to grab the pin for this particular credit card number. If this pin is greater than 2,000, it would then return the results that we see above. Then they're going to try again and see if the pin is greater than 3,000. If there's no results, then we know that the pin is now between 2,000 and 3,000. So they'll keep doing this to try to get towards the pin. So for example, 2,500. If there's no results, now we know it's between 2,000 and 2,500. Then 2,250. If there's results, we know the pin is now between those two numbers. Until finally they narrow down to that there are results with the pin of 2283 and no results with the pin greater than 2284, and so they know that the pin is now 2284. So what I want you to do is open up the course directory and go to SQL Injection, specifically the blind SQL Injection page. Read the page description and do what it says. The goal here is to execute a blind SQL injection to determine the correct CVV. So pause this video, try this on your own, and then come back to compare your answer. Okay, so here we are at the blind SQL injection. So what we have is a credit card number for a specific customer. So if I go ahead and enter this credit card number and hit submit, we will see the customer's information. Now, as you can see here, it says the CVV is invalid because we're trying to figure out what the CVV is for this customer. So here's the query that was generated. So let's go ahead and just guess that there is a CVV column. So we'll say and CVV is greater than, if you don't know what a CVV is, it's the 3 numbers on the back of a credit card. So we're going to check to see if the CVV is greater than 500. Let's just start there. We go ahead and hit submit, and it says the CVV is valid, but not exact. So we need to try again. So since we got results down here, we could then narrow this down a little bit further. Let's check to see if this is now greater than 750. It is not. So we know that that is not a valid number. So let's now try 650, and we got a valid number, so it's going to be between 650 and 700. So let's try 675, and that's not valid. So let's go ahead and try 655. That's not valid either. So let's go ahead and try now 652, and the customer wasn't found. So let's try 651. And it wasn't found. So since it's not greater than 651, but it is greater than 650, we know that the CVV is 651. So I go ahead and hit submit, and we have successfully entered in the correct CVV for the associated credit card number. So now you can see the major issue of SQL injections and not properly protecting against these SQL injections. So here are a few other types of SQL injection attacks that can happen. So for example, string concatenation. With string concatenation, over here in this first line, we are going to end the password input, and then we're going to see if 1 equals 1, which is always, so it's going to say that the users exist. For the second one, we're going to basically change this quote into a literal quote rather than a continuation of a SQL string. When we have 2 quotes next to each other, it interprets it as a literal quote. And so what this is going to do is interpret the username as quote and password equals space, and that's all going to be the username. And then it's going to check, is 1 equal to 1? Yes, it is. And so it's going to find that user. This third example is going to end the username check, and then it's going to check if A equals 8 and then comment out the rest of the code. A always equals A, and so this would find the users. The fourth line is going to now use line comments. So there's 2 types, dash dash space and pound. So this first one, we're going to enter an admin quote space pound as the username, and the pound is going to comment out the password, and so it'll find the users. The second line is going to end the username check and then check if 1 equals 1, which it always does. It will then return the users because the password is then commented out. This third line is going to use a backslash in front of the quote to interpret this quote as a literal quote. So now it's going to say where the username equals a literal quote and password equals space. And then we're going to check or 2 is greater than 1, which is always true. So all the username information is going to be ignored. And then we'll comment out this last quote. Another type of SQL injection is using block comments. So anything between a /* and a */ is going to be commented out. So if we had a query that would insert a new user with a username, privilege, and password, we could say values and enter into the username text box attacker, quote, this would then become the username, comma, quote, admin, which would then become the privilege, and end that with a quote and a comma. And then we start a block comment, which would comment out all the default code. And then on the password text box, we would type in */ quote, add in as the password the word compromised. We can also use query chaining, which is using semicolon, just attaching that to the end of a form entry, such as username, quote, and then semicolon, delete from users, and that would delete all the users from the users table. And then another thing we can do is union. This is mostly for blind SQL injection. So first you're going to discover how many columns there are via trial and error. So you're going to select start from course where the course ID equals 1, order by 6. So maybe start with order by 8, then 7, then 6, and then you finally get results because there are 6 columns. From there, you can then take advantage of those 6 columns by saying select start from course where the course ID equals 1 and 1 equals 2. So what this is going to do is basically ignore this entire query because 1 never equals 2. And then we're going to union a new query. This is going to say select the username and password, and since we knew there were 6 columns returned in this query, we are going to select 3, 4, 5, and 6 from users. So it's just going to display the username, the password, and the numbers 3, 4, 5, and 6, which could lead to a compromise of someone actually being able to see the username and password. So this last one is a subquery where we're going to select start from event where event ID equals 1. Then we have a subquery here. What this subquery is going to do is it's going to get one value from account, and if that's equal to 1, then we know that the account table exists. So this could be used to figure out what tables exist inside of our database. One example that I actually have interacted with was Schmidt Music. They sent me a form to fill out to give my feedback on how they did. So I went and filled out the form with them. I said something like can't inside of the form, and because I had a quote inside the form, it sent me a response, as you can see here. And so what I did is I actually ended up submitting values into this form that would indicate that they were vulnerable to a SQL injection attack. I went back a couple months later, tried the same thing on this form, and it failed because I think they finally implemented my advice to protect against SQL injections. So how do we protect against SQL injections? Well, we need to sanitize the input data by using prepared statements. Prepared statements are going to ensure that injected code is treated as literal data rather than executable statements. So those quotes that we could have used to manipulate the query string are going to be interpreted as literal data rather than a continuation of the SQL string. So for example, inserting data, we're going to give variables to each one of our values. So employee ID, first name, and last name. We are now going to have the query that is generated here, but rather than actually putting 17, Billy, and Blue Jay here, we're going to put question marks. And then we're going to prepare this query with each one of these variables that we are going to provide right here. So essentially these variables are going to be plugged into each one of these question marks to ensure that this is interpreted as literal data rather than a continuation of the SQL string. Same thing for querying data. We give the first name and last name Billy Blue Jay. We're going to select start from employee where the first name equals question mark and the last name equals question mark. We're going to prepare this query and then we'll execute it with the first name as the first question mark and the last name as the second question mark, and this would successfully protect against that SQL injection. If you're not going to use the PDO format for PHP, rather if you use MySQL, make sure that you don't allow multi-queries, so this would protect against stacked SQL injections. Another type of SQL injection countermeasure is that of prepared statements through stored procedures. So just like what we showed you with PHP, we're going to prepare our statements and execute those statements prior to plugging in the values directly from the query itself to ensure that our database is protected against malicious code and it interprets it as literal data. And for your enjoyment, here's a SQL Injection Comic. This is from XKCD, which is a great site if you're interested in technology comics. So this mother answers the phone and the person on the other side says, "Hi, this is your son's school. We're having some computer trouble." "Oh dear, did he break something?" "In a way." "Did you really name your son Robert, quote, parentheses, semicolon, drop table student, semicolon, dash, dash, space?" Oh yes, Little Bobby Tables we call him. Well, we've lost this year's student records. I hope you're happy, and I hope you've learned to sanitize your database inputs.